Welcome everyone to this sixth webinar hosted by the SWAN APAC Alliance. The Alliance is part of SWAN, the Smart Water Networks Forum, a nonprofit which is a leading global hub for smart water and wastewater sectors. Good morning, hello, I'm Patrick Bonk. I'm a global product marketing manager with the software company Innovyze, which is an Autodesk company, and I'm also co-chair of the communications group within the SWAN APAC Alliance. So getting started this morning or this evening or this afternoon, wherever you're calling in from, what is today's value proposition of the presentation? Well, digital twin technology for the global water industry, we all see such promise in such innovations, but once you're on your digital adoption journey, fundamental questions will arise within yourself and your organization. How do you get started? How do you know where you are going? And what does success look like once you've started? And often we're very siloed in this digital transformation journey as organizations. So SWAN's Digital Twin Workgroup was designed to provide value for you in each step along the way, along this journey. And today we're going to hear from industry thought leaders from each of SWAN's digital twin subgroups. That's the holistic architecture, the digital twin lifecycle, outcomes and applications, the BIM and asset management. And then we'll also hear from Clarissa Phillips about Sydney Water's digital twin journey. We could have next slide. Next one after that. Thank you. So the SWAN APAC Alliance works to accelerate smart water and wastewater development in Asia Pacific region through the SWAN Forum's collective industry expertise and collaborative partnerships. The Alliance offers access to specialized webinars, workshops, and a central source for smart water and wastewater information. Next slide. And the APAC Alliance is a volunteer-led and guided alliance planning group. So each of the subgroup, the communications, the partnerships, and the research subteams is dedicated to accelerating smart water through a value-based programming and cutting-edge content to utility-driven case studies. And lastly, before I hand this off, the APAC Alliance is composed of a mix of utilities and solution providers. This slide is a snapshot of our new member ecosystem on SWAN's new website. The new interactive ecosystem will allow you to filter members by category, region, and solutions. Current APAC members, we're up to 68 members that have market operational based in Asia Pacific. Our goal is to increase our presence in the region and to involve new members outside of Australia. One way we can do this is through our events and collaborative projects and our partnerships. So I'd like to take this opportunity to hand it over to Gigi Karmas-Edwards, who is going to introduce the SWAN Digital Twin Workgroup and today's speakers. Over to you, Gigi.
Thank you so much, Patrick. Yeah, this is a very exciting webinar. We're trying to really do a lot of integration between the APAC region, a lot of developments happening on this side of the globe in digital twin. We want to make sure it's completely integrated with the other side of the globe. So, I want to introduce a little bit about the Digital Twin Working Group, and hopefully there's going to be a lot more conversations on these different aspects of digital twin. So could you go to the next slide, please? So first of all, what are the objectives of the Digital Twin Working Group? We developed or created this working group about 3 years now. It was back in 2019. And the main idea is to raise awareness of digital twin concepts. We want to identify the challenges that most utilities are facing when they think about how did they get started on digital twin, like Patrick was saying. And then collectively through experiences of different utilities around the world, put together some of the best practices to help other utilities adopt and go on their journey for digital twin. And of course, the overall objective is to increase adoption of digital twins across the global water sector. When we first started the working group, we decided at the very first workshop, which was in May of 2019 in Miami, to create two sub-working groups to really concentrate on these two areas. One is the holistic architecture, which you're going to hear a lot about, and the architecture diagram that came out of that group. And then we also wanted to work on the outcomes and ROI to really help other utilities build their business cases so that they can also get on their journey. As we got more and more into it, we realized that really there's a whole life cycle of using digital twin, because digital twin did not come from the water sector. It's been around for decades, and other sectors have done quite a bit with digital twin. And so we realized that digital twins can be used in the design phase, the construction phase, the operation phase, as well as maybe some customer experience phases. So we decided to create another sub-working group, Digital Twin Lifecycle. And from that, as we got more into design phase, as you're going to hear from Clarissa later on today, BIM became a big part of that. And BIM, Building Information Modeling, was a term that's probably pretty well understood in the UK region and maybe in Australia. But in some of the other parts of the world, BIM and the water sector, they weren't using building information modeling as much. So we decided to create another sub-working group, and we collaborated with BIM for Water, and you'll hear from the co-leads there, and really focus on BIM and asset management and how that pertains to digital twin. So with that, high-level overview and introduction to the Digital Twin Working Group, would love to get all of you involved. There are many calls that are happening in each of these subgroups on a regular basis, and would love to hear from all of you and get some input. So I'd like to introduce the first sub-working group, which is going to be BIM, Digital Twin Lifecycle. The co-leads are Agnes Pedersen and Yuri Emmerling. So welcome, guys. Thank you.
Thank you, Gigi. Hello, everyone. My name is Yuri Emmerling. I'm working for a utility in Flanders, Belgium. And I'm co-leading this SWAN Digital Twin Workgroup on Digital Twin Lifecycle together with Agnete Pedersen. Next slide, please. Okay, thanks. So what is the working group about? I guess that most of you know about asset management, where you follow your assets throughout their entire life cycle, where you start with the planning phase, then you go to a conceptual and detailed design phase, go on to a procurement and construction phase. Then later on, once assets have been constructed, then you go to an operations and you have to follow up with maintenance. And then finally, after a while, you need to think about the end of life of the assets and how to deal with that. And with that, you also have data that belongs to that. We have historical data, we have technical and financial data, real-time data in operations and maintenance phases, then looking also at technical and financial data for end-of-life decisions. And this is all typical data that belongs to all these phases, and some of them is different between the different phases. Some is data that can be reused. And something similar do you have also with the different models that you're using in different phases of this asset life cycle, where you have design models which are maybe a bit more conceptual or already in a certain detail, but you don't have the plant itself, so you cannot have operational data in there. You have financial models to make your decisions. You can have models for maintenance and do predictive maintenance, or operational models to support your operators in decisions that they have to make on a day-to-day basis. And again, you also have these financial models. And also there, you have the interactions between all those phases, between data and the models, but also along the asset life cycle, you can reuse parts of the data. So actually, instead of only looking at asset lifecycle management, I believe that you also have to go, and can you click once more, Shane? You have to go to, and once more, to both data and model lifecycle management, because that's creating value for your data, for your models, and it's doing also a cost optimization, because you can reuse parts of the efforts. And actually, the same thing you can is true for digital twins. So how can we look at different digital twins, and how can we reuse the knowledge that we have for one type of digital twin and other types of digital twins? And whereas most of the working groups are focusing on operational digital twins, you also have digital twins that you can use in all these other phases, like construction phases or planning phases. And so that's the reason actually for, you know, you're going too fast, Shane, I can go back one. That's two, actually. That's the reason for this working group. So there we want to create a diagram demonstrating that we have these different types of digital twins, but also we have different levels where we can play with digital twins. You can have a digital twin for a process unit or an assets type, but it can also be a digital twin on the plan scale level, or even a city level, or even on a region level. And also there you can have interaction between those different types and levels. So in this working group, we also want to gather and share case studies so that we can learn from each other and share information on how we maintain those digital twins and update them with new information that you can acquire, and how we connect those digital twins between all these different types and levels. Next one, Shana. In order to get a bit an idea, because we're rather new with this working group, and also Ognette and myself are relatively new co-leading this group, we set up a survey to have an idea what people would be interested in view of the life cycles of digital twins. So with this, I ask you to have a look at this survey and fill it in, and you're definitely welcome to showcase ideas that you have that in the working group. And with that, Ognette, I think you can take it for the next slide here.
Yes, and just to say a few words what we have done so far, and this is also what was done from the previous group, of the previous co-leads of this group, is that that we try to have interactive discussion, and you and I will still believe that we want to have this, and also peer-to-peer learnings. And this is an example of a Miro board that the previous co-leads made, where we had a lot of post-its to highlight what we understood for the different stages that we have. Next slide. And also that we have a lot of use case presentations, and we believe that this will be our main topic, that we have at least one use case presentation at least in the beginning here, and we have had some from Brazil, and also me telling about our structure of our models, and then we also had a Finnish PhD student who told about his PhD project about digital twins and how he see digital twin web. This was the most recent. And next slide. So just to say that this is what we operate with currently. This is the digital twin stages, the 4 of them: planning, design, construction, and operation. And then we also have these kind of levels where we can have this wheel in each at each level. And then our task is how do we interact, so we reuse a lot of information obtained from the different stages and the different levels to be to put in to other digital twins in different levels or stages, like Yuri told us. And we would love that that we also have use cases from the APAC community. Yes, thank you.
Okay, and with that, we can hand to the next working group on building information modeling and the links with digital twins. And I believe Jamie will tell you all about this.
Thanks, Yuri. And unfortunately, you've just got me this evening, this morning, this afternoon, wherever you are in the world. Chris is not able to join us. So full-time, I work with Xylem, and I look across 29 product manufacturers that we own, and I'm looking at a corporate solution for building information modeling, which of course fits into this group. I've also, for the previous year or so, headed up our global digital twin initiative. So rightly so placed within this subgroup. Let's have another slide, please. So And Gigi, thanks for giving a bit of background to, you know, where this group came from. But the purpose was to sort of build on BIM as a building block, so building information modeling and the work that had been done with that process and methodology that's now been, you know, rightly so put into international standards, ISO 19650 and the like. And I want to just take a bit of time to explain the work of BIM for Water, which I'll do momentarily. The other point of, you know, this subgroup is to really build a standard process for developing digital twins and to help connect into the other groups and to see where BIM forms a part of information modeling and how we can structure and create data sets to then build on and you know, make better informed decisions from. So next slide, please. So BIM for Water isn't new. It's UK based. However, we do have partnerships with Australia and Germany. I'm the current elected chair of the group, and I'll hand that over in June of this year. But established in 2013, there are now 8 active task groups, and I thought it might be beneficial for those on the call just to have a little dive in to see what they do. So starting at the top there with data quality, you know, that's all about maturity and you know, the quality of data that we feed in. What are the standards and what is the guidance around that? The Water Data Task Force, that's certainly centric to digital twinning and actually looks at sharing information between sectors. So that could be energy and water or telecommunications, for example. The WICS's group, which I'm not going to read that out because it's quite a mouthful, but that really looks at the ontology. So that's classification and hierarchy, and they have a partnership with Uniclass as a classification system and look to align certain classifications with water industry. So for instance, specific equipment that we use, like say sludge scraper, we want to ensure that there's a globally unique identifier within a classification system that suits our industry needs. Skills, of course, is all about, you know, people. They link in with academia and make sure that we've got the right resource to drive digital transformation and to get us to a position where we can do that. The standard libraries group at the bottom there, that's all around having standard data templates for the exchange of information. And that's a piece of work that we're working on within this subgroup. And I'm going to explain that further. We're moving swiftly on. The greater than 4D, of course, the fourth dimension being the element of time. They look at really, you know, how we deliver. So how do we model information through project delivery and structure it? And they have some great guidance on that. Owner operators, of course, is you know, close to water companies, and you can see there that they're actively working with 20 water companies within the UK, and of course regulators, and looking at things like, you know, what does a good common data environment look like for managing and exchanging information, and then how will we store that information in, you know, an asset management system, etc. And then, you know, the final group there is all around capturing that and presenting case studies. There's a roadmap, and you can see there's a link, and I encourage anyone to, you know, have a look at a link or similarly follow BIM for Water's activities on LinkedIn. Next slide, please. So before I, you know, really dive into what this group's currently working on, I thought we could take a little bit of a step back and think about, you know, what are we actually talking about here? And I like to think of anything that we go out to build is really just a system of systems. So it could be things that move, so dynamic systems, or things that don't or shouldn't, static type systems, and they should be connected to the natural environment, right? Unless it's a satellite or something like this. And of course, working together, we want these things to have functions that feed into a process or a purpose. And you know, if we break these systems down, we could argue that these are actually just discrete packages or products that are connected together and are, you know, working together to form these functions, processes, or purposes. And I think if we were thinking in that way, you know, we could say that if we look through the life cycle of a built asset, that if we wanted to model this or build a mathematical model or an information model to help us make better informed decisions of that, we really need to start to understand what these things are and how we can connect that information, that data together and structure that, and perhaps in a machine readable way. So at some point in the future, we can go back and interrogate it and, ask questions. So next slide, please. So I know this looks quite busy, but one of the focus areas of the BIM and Asset Management Group at the moment is to build on work that BIM for Water's done in creating industry agreed product data templates. So, the group's working through and looking at quite industry specific equipment, and there's a review process where as an industry, as experts in our field, we go on and agree particular property groups that we feel will be beneficial for the design and the operation of equipment. And of course, these properties will help us make better informed decisions about, say, embodied carbon or predictive maintenance, etc. So where does that go when we start thinking about systems? Well, if we're connecting things together within a system, and you can see it there in the dotted box, we could then perhaps start thinking about, what is the purpose of that system. And one of the focus areas of this group is to say, well, okay, if that's the point, let's think about having a digital process block. So an actual framework that describes how different products work together to perform a function. And of course, that function could be moving water about, so say pumping, and then within that digital process block, we could then start to prescribe, well, what products need to go in there? What's the product data template that we need to build up? And of course, if we're thinking in this way, we can then, start to pre-think about the sort of things that we want to interrogate. So if we want to look at performance and measure that within a digital twin, or make better informed decisions of that, what sort of sensing technology do we need to build into that system? And it's thinking in this way that we can use these digital process blocks or frameworks for information to start to build up a larger information model. And of course, we can embed these into the requirements of a project using the principles and methodologies of building information modeling as outlined in the standards to really, drive how we think about our industry specific systems, etc. So let's go on to the next slide, please. So the work so far, we've really split it into two items. So on the left hand side, you see a snip of a development procedure. So what we're aiming to do here is to document how we would go about defining what a digital process is, what that means. So give a clear definition, an agreed definition to what that is. And then, within that, we can then start to prescribe, what sort of things we need to include. And that could be things like the data templates as discussed, or certain types of analysis that you might want to include to get a particular use case. So if you was trying to measure the total efficiency of a particular process, these are the types of things that you need to include. And getting a consensus on that, we can then prescribe a formal process for us as experts working in our industry to go through and agree on a standard process block. In parallel to that, we're also doing that work. So, this is really Chris's baby and he's driving this, but we're going through and we're producing draft digital process blocks. So you can see there that, there's 6 in work at the moment, and we're looking at particular functions and processes like pumping, clarification, etc. And, really trying to identify what are the core products within that, what are the things that we might want to measure, and providing a framework, a type of guidance that we can use, almost like an object that we can drop in and say, these are standard shared industry requirements for water moving forward. And of course, through doing that, we'll be building the information model for which a digital twin can be built from. So it's a foundational work. Next slide, please. Thank you. I'm going to hand over to Andy and let you talk about outcomes and applications. Thank you very much.
Brilliant. Thanks, Jamie. So I'm Andy Smith. I work for Anglian Water, and I'm the Smart Water Strategy Manager, which includes everything in water, not water recycling, except from smart meters, which might seem strange. I have the pleasure of co-chairing this work group with Pedro, who unfortunately can't make it today. So if we move on to the next slide, if we can. So the agenda today, I'm going to just cover off that big question is, why do we need digital twins? And then I'll give you a brief overview of the outcomes group. So the outcomes group, we've decided to focus on 3 key elements. So one being insight, the next one is around people, and then the other one is around business transformation. Then I'll give you a summary and a bit of a whistle-stop tour. So if we could move to the next one, please. So why do we need digital twins? So in Anglian, obviously, we're building our smart water system, and a fundamental part of that is digital twins. And we recognise that actually, we've got a number of issues within the business, but fundamentally what we're trying to do is connect our assets, our people and our processes. And when you start to look at the SWAN model with regards to creating that smart water network, what we need to make sure is that connecting our assets, people and processes links to our strategic outcomes. Now they can be different for every utility. So you might want to just focus in on one particular strategic outcome with a digital twin, or multiple across your whole system from source to source. So, there's just a few up there for me in terms of efficiency, and that's really important for us because that really is about your business health, particularly in the UK with regards to the regulator. We're always being driven on efficiency, and also how that then affects in terms of customer bills. Carbon reduction might be one, resilience in terms of climate change and how we adapt to that, customer experience, water resources management, water quality. So you can pick a number off the list, or you can just have one. So if we can move to the next one, please. So when we talk about outcomes, this is about insight. So this is the first group. So we all need insight to drive improvements in terms of our system performance when we look at those physical assets, the investment decisions that we make as a utility, and also around customer engagement and customer satisfaction, because these are really important. If we're not driving those things, actually, customer is one of the key elements here. And I've just picked on one example. So you can see on the left with regards to system performance, there's the sort of value pyramid, moving from descriptive right the way through to prescriptive, right? So within that, and I've given you some Anglian Water outcomes, and the things that are in bold there are really those big sort of like chunky items that we're really focused in on in the organisation. So when we look at that descriptive element, we want to know what is happening. So the outcome that we want is we want to be able to view and understand live system performance, which supports near real-time or real-time decision-making. That should reduce rework, so then drive an efficiency, improve the safety of our people, but also then mitigate the impacts to our customers, so they're happy with our service. When we look at the diagnostic element, why is it happening? So we use that system information, identifies issues such as leaks, bursts, in a much quicker time frame to what we currently do. We have water quality complaints, joining these data sets together to determine the genuine root cause of failures or issues within the business. This then drives efficient use of our field resources and also our assets as well. Issues are resolved first time, and that obviously then has a positive impact on customer and also reduces customer impact. So when we get to the predictive element, what is likely to happen? So very, very interesting in terms of forecasting. Yet again, the ability to use sensor data with our existing systems, providing trends, early warnings, and be able to forecast our capacity and capability going forward. This becomes really interesting for us in terms of summer. We are a water stressed area, but also really important to us is around things like energy efficiency. And actually this is becoming more of an issue in the UK at the moment with the cost of energy going up. It also then directly links to our reduced cost to serve and also our relative efficiency to other companies which we are measured on. It also then means that we start to think about calmer networks, reducing NRW, which is a real focus for us in a water stressed area, and then ultimately again minimizing customer impact, but also when we're reducing leakage, our customers are happy with what we're doing. Then we get on to the sort of holy grail around being prescriptive, what should happen. So the model should provide those solutions and proposed actions that we need to take, such as optimum pumping schedules based on that near real-time data coming in, and also how we manage incidents within our organization as well to minimize that impact to customers. And then what really need to see there is this reduced human intervention. So what we've seen already with the implementation of some of our twins is around the fact that we're not sending people out at night. We're not working in the highway as much to carry out what would normally be a routine activity. And then that's also driving efficiency linking to those carbon goals that we've had. So if we move on to the next one. So that's very asset focused. But actually one of the things that we've thought about in this group and I'm really passionate about in terms of outcomes is what do digital twins mean for our people? So our people should be at the heart of that digital twin journey. You know, what we need to make sure of is that our workforce are empowered with these new digital solutions, that we take the mundane and the routine away and we actually enable them to be creative and more effective and efficient in what they do. It must make our people happier, healthier and safer. There's a lot of stress in the workplace, and actually what we need to do is try and make it as an exciting, enjoyable thing to do is to turn up to work. It should fundamentally shift the way utilities operate. So as I said, getting rid of those mundane tasks and actually getting people engaged with their job on a daily basis. More efficiency can be achieved with the use of the digital twin as well, and everybody can see that and visualize that as well. So it becomes very important in terms of how we drive efficiency within the workplace. And efficiency is not a bad thing. It doesn't mean that actually you need to do more, you just need to be more effective in what you do as well. Digital twins should help with the aging workforce debate. We have a high number of people retiring in the next 10 years within Anglian, but what we also need to do is attract new people into the organisation. And actually, you know, younger people are fully familiar with digital solutions, and what we can't do is bring them into an archaic organisation which does not embrace digital. Fundamental to anything that we do is around employee engagement. It's absolutely essential. It helps drive cultural change rather than cultural change being enforced on people. And that leads to a future business operating model which is sustainable for all. And that's, we'll move on to the next slide. So when we start to think about the outcomes, business transformation is really important. So, you know, we can't continue to operate like we do. And this is really about what it means to the boardroom in a lot of respects. So how do digital twins influence that future business operating model? This is something we're really focused in on. What skills are required within our organisations going forward? How do we get ready for this now? What cultural change is required to get successful adoption? So this is all around engagement, as I've spoken to you, speaking to those people that are actually going to use those twins, getting the impact. There's no good us putting in solutions to problems that they haven't got. We need to solve their problems. How to help digital twins help build trust with regulators? You know, what information do regulators want to see from us in near real time going forward, rather than a set of annual reports? So it's about building trust with those regulators. How can digital twins help us adapt to things like climate change and improve our environmental outcomes? In the UK, there's a lot of focus at the moment in terms of pollutions of rivers, from sewerage systems that are quite ancient. So how do we improve those environmental outcomes and get ahead of those spills before they happen? And then how does a digital twin align with an organisation's purpose, values and strategic outcomes? So I've put our purpose on there and also our values. So we talk about doing the right thing, building trust and always exploring. And I think digital twins really do align with that. And when we look at our purpose, it's about bringing in environmental and social prosperity to the region we serve through our commitment to love every drop. So within Anglian, you know, our look at business transformation is that our digital twins all must point to those goals and outcomes. So if I move on to the final slide, which I think is around just a summary. So the digital twin decision in your organization moving towards embracing digital transformation really needs to be linked with your purpose, values, and strategic outcomes. Start with the business strategic objectives that you're trying to solve, and importantly, the regulated outcomes which mean most to you. Digital twins also must provide insight to make us make better, improved decisions around a number of things in terms of customer investment decisions. And significantly, a lot of people talk about the technological change that's actually required for us to do that. So, you know, as organizations, we're probably data rich, information poor within the water sector. And fundamental to that is a cultural change. So, you know, we think about valuing our assets, but what we need to do is get a cultural change which starts to value data, because data underpins all digital twins. And they should be viewed as an enabler to business change. Cultural adoptions needs to be considered early on, and this is where we talk about engagement with your workforce, defining how your people will interact with those digital twins, what outcomes will they get, and completing a circular feedback route. So it's not just information going down to them, it's how they interact with the information to make better decisions on the jobs that they actually do. And then the key one, which we've been struggling with quite a lot, is the return on investment. So I think that depends on the size of the organization, what you're trying to focus in on. But I think the key there is that your return on investment needs to be linked to your strategic outcomes, because if you're delivering your strategic outcomes, you know, from a regulatory point of view in the UK, we would be in reward, and it gives confidence, builds trust in your organization, and then your customers are fully engaged with you as an organization and what your purpose is. So that's me, and I'm going to hand over to Chenzi, who's going to talk to you about the digital twin architecture.
Thanks, Andy. My name is Chenzi, and I work for DHI. I'm a business innovation manager, where we try to change the way we innovate internally at DHI and also openly with partners. Together with Michael from Brown & Caldwell, we lead the Holistic Architecture Subgroup for the Digital Twin Working Group. And what this Holistic Architecture Subgroup focuses on is really on the technology side of the digital twin, and how we as an industry can come together and further push the adaptation of digital twins. One of the key obstacles we see is really to get an alignment as an industry of what we all think is a digital twin. And our view is that if we can all agree on what a digital twin is, you know, sort of a common language of, you know, where we can better see where we fit in as technology providers, consultants, how can we jointly work together to design and implement digital twins for utilities, you know, the better we can progress the implementation of digital twins. As a subgroup, we're working on a white paper, which we are excited to launch at the upcoming SWAN conference. But I'll give you a very quick tour or snapshot of what our thoughts are in the white paper. And we start off with a, you know, a definition of what a digital twin is. What we've experienced in our subgroup discussions is that different people, different organizations have very different views of what a digital twin is. Some say it's a model, some say it's a 3D visualization. And in our view, we think that a digital twin really is a dynamic representation of a real world system that, you know, that can be used to describe, diagnose, predict, and optimize through actions enabled by combination of models and data. It's a bit of a mouthful. If you go to the next slide. So we come up with this digital twin architecture, and we really like to use this architecture as a framework to explain what a digital twin is, what the components of the digital twins are. And if you look at this, we start off from the left side with the physical system, the assets that we have. It can be a distribution system, a collection system, or a wastewater treatment plant. And we progress from the left to the right side. We move on to the sensing and control part, where you could have different sensors, actuators, different types of monitoring devices that allows you to get a view of what is happening within your assets and within your system. And then you go on to the next box, where it is on the data collection sources. So we would really like to combine different types of data that you have in a utility. And that can be from different systems, different SCADA systems, different business management systems. And once you have all this data collected kind of centrally, then you can start to do the fun part, which is the digital twin section. And start off with the data integration part. You need to combine different types of data for any analytics to work on. So the data ingestion, the integration, the management part of data is really important in a digital twin. In the analytics side, we kind of split it up into two main types of analytics. We have the more classical physics-based models, it can be hydraulic model, biological model, and so on. And then we have the data-driven models. So that's where the AI models or machine learning models, pattern recognition models come into play. Once you have these models, then you can start to visualize the insights of the information from these models. And then you go into the user experience to help you make different decisions that you would like to achieve for your digital twin. So if you go down to that the point there, so from user experience, you go into informed decisions, and I think the key thing here is really to take actionable results from your digital twin and implement it back into the physical system. So you have that complete loop between the insight analytics that you produce, the actions that you take, and then you sense what is happening in your physical system, and the whole loop kind of goes as a closed loop. At the bottom, we have this secure and connected utility, and I think all these things has to be secure in a secure environment so that your data and your operations are safe and secure in the digital twins. Next slide, please. Just keep clicking, share. So, what can you use this architecture for? Can you go to the next slide? Yeah, so I borrowed this this slide from Anglian Water, and it's really a nice way. You can see that the digital twin architecture is it's a good framework to map out all the technology components, vendors, the projects that you may have to get an overview of the starting point of where your digital twin journey is. And if you go to the next slide, this architecture also helps to answer questions like what's the difference between models and digital twins. So you can see that the models are really part of a digital twin in the analytics box, and they're very specific to a process, whereas the digital twin uses different types of models in an integrated way to try to achieve the outcomes. So in our line of thinking, we have the digital twin architecture to map up all the components and the different technology projects that you may have. And that is really the starting point of your digital twin journey. If you go to the next slide. We have discussed and identified, 4 pillars of a digital twin journey. And these pillars can really help guide how you can go through the planning and implementation, the road mapping of your digital twin. And one of the first pillars is outcomes. And Andy has also stressed earlier that outcomes is really the driving force of what your digital twin can do or should do. And these are kind of the desired goals that you want to benchmark for achievements. So we also like to stress that outcomes is really one of the key pillars of your digital twin journey. The next pillar is connectivity, and it's about how much of your sensors, actuators, models are connected, because depending on your connectivity of your assets and your data and your model, you may or may not achieve the outcomes that you want. So within that connectivity pillar, it's a good way to gauge where you are in your connectivity part of the journey. The next one is insights. And this is about how much information or insights you can generate from the data that you have, that you get, and also the models that you have in your system. Here we are a little bit more open to the idea that for example, physics-based models, they are pretty good at kind of simulating the optimal design conditions of the system, whereas a data-driven model gives you a better view of what are the actual operational what are the actual operation performance of your system. And by combining this data-driven models and physics-based models, they allow you to generate better insights, which you can then use in the next pillar to make interactions and actions. We really would like to see that a digital twin is really not complete if it doesn't take any actions. It doesn't provide any decision support to the user. So these interactions and actions are important, and it can be human interactions and actions to the systems, or it can also be machine interaction and actions, kind of in an autonomous way to your system. So these are the 4 pillars of a digital twin journey, and we think that could help guide how you can plan and progress the implementation of a digital twin. Next. Yeah. So passing on to Clarissa for the case study.
Hi, everyone. We go to the next slide. So Sydney Water is the largest water utility in Australia. We provide safe drinking water to more than 5 million people across Sydney. We also provide wastewater services. And as you can see from this slide, we own a lot of assets, which I'm seeing at the moment is providing our team with so much opportunity to build some amazing digital twins and enhance the way we work. Can I get the next slide, please? Now, the Sydney Water approach to digital engineering, we have 3 key areas that we're focusing on. And my role at Sydney Water is a digital engineering integration specialist. I work with the delivery teams to deliver BIM models. And I make sure that that information that's coming in the BIM models can be integrated into Sydney Water systems and can be used to manage and maintain our assets later on. And I also share this knowledge with our digital twin team. And the next one is the industry. We work with organisations such as WASA and BIM for Water, and of course SWAN. And at the moment we're working with WASA, and I'm in the WIX group, to develop our Uniclass classification system. And we've got a project going at Sydney Water to see what that looks like at Sydney Water and whether that's valuable. The next slide, please. So we have developed a maturity framework with our delivery partners to stage the implementation of digital engineering projects. And we're now in year 2, which is a collaboration phase. And that's really where we're trying to stage that approach and build up those capabilities throughout the years. So I call it the BIM before you twin, I suppose is a good way to put it. So you can see that the BIM goes to really year 3, and then in year 4 to year 10, you really see those capabilities building up, and we start getting into those digital twin capabilities. Can I get the next slide, please? Now, I don't have a shiny digital twin to discuss today, but I'm going to share with you the process that we're going through and try to work out what Sydney Water's digital twin is going to look like. So first of all, we came up with a definition of what a digital twin is for Sydney Water. A digital twin is a virtual representation of both our physical, natural and built assets and systems that is used to deliver business value and improve lifecycle performance with informed insights to enhance the experience for the benefit of our people, customers, the environment and the city. Now we've engaged in a consultant to assist us to build a business case, which has a variety of use cases and showcases. And we've also had several internal workshops with different parts of the business to engage with the different teams and build a variety of those use cases and connect with the different business areas within Sydney Water. Can I get the next slide, please? So we've developed a digital twin maturity matrix, and that matrix will categorise what digital twin is in 5 categories and to look at that digital twin through a technical lens. Some of the use cases that we're developing might be in one of these or in several. And for example, category 4, our federated digital twin, which will show federated, synchronized and interactive for planning and operations. And that can include things such as our combined digital twins and, you know, our New South Wales digital twin. And how can we get our federated digital twin to work with that New South Wales digital twin, and what data we can share and what can we leverage off them. And then when you look at category 5, I've got a picture of our actual robots that go into the sewer network. So we send those robots into our pipes to identify cracks. However, we're not enhancing what we get from that robot, such as we're not collecting GIS information. So how can we leverage the data we get from existing projects in Sydney Water and enhance that data and information through the development of these digital twins? Can I get the next slide, please? So we're using the SWAN capability architecture for digital twins, and I thank you, Chenzi, for going through that and explaining how this works, and this will make my job a lot easier. So we've broken down into 7 digital twin components and really numbered them 1 to 7 from the physical system to the user experience. And we're using those in our workshop really for everyone to help visualise and to develop our digital twin use cases together internally. So we've also made it software agnostic, so we can easily integrate these capabilities with third-party software providers, for example. Can you go to the next slide? And then this just shows how we've expanded that and used the numbers 1 to 7 to show this. Could you go to the next slide, please, which will have some more information. So this is our strategic capabilities for Sydney Water, our current and planned capabilities and how some of our current projects can connect to our digital twin use cases. So do you want to go to the next slide? So from these workshops, we ended up with 144 use cases, which is a lot. And we've got that down to 11 to be shortlisted. And we use that by doing optioneering and discussions with the heads of and management teams. And yeah, and we've developed those into 5 showcases, which is better information management, capital planning, operations and maintenance, customer experience, and digitalisation, smart city. And I'm only going to share 2 today because I don't have enough time, but could you go to the next slide, please? So use case 24 is asset and performance indicator optimization and visualization. And we've put that in, sorry, I can't see this slide. Yeah, so we've got required capabilities and possible additional capabilities here shown in this slide. And if you go to the next slide, we give a bit of a description on how we're doing this. So our user story out of this case would be, as an asset manager, I want to be notified of asset failures and faults earlier so I can reduce inoperative costs, reduce equipment downtime and optimise the use of equipment. And the showcase category we've put that in is better information management. Can you go to the next slide, please? And our next use case, 21, asset performance simulator. And as you can see, these are the acquired capabilities and possible new capabilities we can bring to Sydney Water by having this showcase. And if you go to the next slide, I've got an explanation on what we found there. So the user story for this one would be, as a treatment plant operating manager, I want to have a clear and holistic view of my treatment plant's performance now and into the future so that I can manage my team's work schedule and assist in designing inspection and maintenance programs. As a treatment plant inspection engineer, I want to be able to access live data on equipment performance while on site. And the showcase category for this one is operations and maintenance. So as you can see, we're taking a holistic approach to understanding what Sydney Water Digital Twin could look like, from the development of asset information models, receive and delivery, to how we can optimise the way we work by developing a digital twin with these use cases that bring the best value to Sydney Water. Building a digital twin is a huge transformational piece for Sydney Water. What I've learned is you need to engage with key stakeholders early, as these stakeholders will be the ones driving this transformational change with you and using these digital twins in the near future. Thank you.
Thanks, Clarissa. All right, that was an action-packed presentation webinar session. I think we have time just for a couple questions. One that has been coming up is, how can people get more involved in each of the subgroups with the Digital Twin Working Group?
I think I can answer that, Patrick. Well, one of the things is all of the sub-working groups, they have a timeline. I think it's actually published now on the SWAN website of when they're meeting this year. So I think we've already pre-arranged a lot of the meetings. You could also connect with all the co-leads. You saw all the names right now of the co-leads of the 4 sub-working group. Connect with them, ask how you can engage more. One of the things, because of the time difference, that we thought of doing, and we're working with Patrick and Alana on this, is, you know, we're going to do the recordings of every single one of the sub-working group meetings, have the people on the APAC side look at that, focus on one subgroup at a time, look at those recordings, and then hopefully record your meeting on that particular sub-working group. So let's say it's a BIM and asset management, then record your sub-working group and add to it. And then hopefully that will go back to Jamie and Chris, and they could look at that recording, understand some of the conversations that you've had, address some of the issues and ask some of the questions. And perhaps that way we can go back and forth between the 2 sides of the globe on some of these sub-working groups. But definitely connect, get in touch with the sub-working group leads, and start that conversation.
Wonderful. This question's in relation to that. I think it's for Jamie with the BIM and asset management group. Will the process blocks be made freely available, and how do they get in? How can people get involved with the development of those?
Yeah, thanks, Patrick. And I think that's a great question. And absolutely, you know, the idea is to share this information freely, and of course, also the agreed product data templates that feed into them. So that's certainly on the agenda. Yeah.
Thanks, Jamie. I think to wrap it up, I just wanted to thank all our brilliant and thoughtful speakers today, and all of you for joining. Just quickly, in terms of being involved with the APAC Alliance, we have an ongoing LinkedIn takeover. So this is your opportunity as an organization, whether you're a vendor, a research institute, utility, or council, to take over the APAC Alliance LinkedIn feed. You can also join one of the digital twin subgroups, as we discussed here today. And then also with the APAC Alliance itself, we have a partnership, a research, and a communication team call on a bi-monthly basis. So those are collaborative calls that we have, and we have guest speakers as well to continue this collaboration and to offer that regular expertise and touch points through the year. As well, access SWAN Global Conference recordings via the members page on the SWAN website. So as a SWAN member, you have access to a treasure chest of online SWAN Global Conference recordings and digital resources. And this is the leading and latest thinking and continuing this conversation that we've had today around digital twins and digital transformation in the industry. Oh, that's a mouthful. Okay, thank you everybody for today. All the speakers were brilliant, and I really appreciate you attending. Have a great one. Take care.